Hi everybody. Today we have a lot to go over, a real lot. We're going to start with what is radian. It's kind of maybe a weird thing to think of. So we start with just a radius and we draw a circle. So there's your radius. Then we're going to kind of straighten it out and bend it so that it fits around the circle. So now it's called a subtended arc. That's an arc, and so we're just draw the central angle. So there's 1 radian. That's about the size of 1 radian. And any circle would be like that. There's 2 radians. We copy and paste, there's 3 radians. And there's this tiny little sliver left. That's about 0.14 radians. So that's actually pi radians. Fits in half a circle. If we double that, and we get 2 pi radians, makes a whole circle. So that is what a radian is and how it's created. And obviously it can be done for any circle. So I hope that kind of brings it to light a little bit. That's basically what they're trying to tell you here and here. Kind of hard to read and imagine what they're saying, but that's what it is. So an angle theta, is 1 complete clockwise or counterclockwise rotation, of course, all the way around is 360 degrees. And in radians, that is 2 pi. So 2 pi is all the way around, as I just showed you. And then, of course, that's 360 degrees. So we get 360 degrees is all the way around. And that is in radians, that is 2 pi. So 1 degree, if we think about dividing this out, if we think about putting these two things on top of each other and making a proportion, we reduce that. 1 degree is pi over 180 radians. And 1 radian, if we flip that over, is 180 over pi degrees. So these values are kind of obscure in terms of what is that actual measure. But we don't really think about it like that. These are just the conversion units or the conversion values we're going to use to switch our units from degrees to radians and back and forth. So it's all about pi. So if you don't have it, you want it. And if you do have it, you want to get rid of it. So if we're trying to get this to radians, we're going to put the pi on top. So we're going to do pi over 180. So we just multiply by pi over 180. You can actually put this in your calculator. If you're bad at reducing fractions, don't put the pi in the calculator because the calculator treats pi like the decimal it is. Just put the 45 over 180. Make the calculator reduce it for you. Put the pi back in the numerator. This is pi over 4. If it's negative, it stays negative. So we're going to multiply again by pi over 180. You reduce that a little bit, and we get negative 7 pi over 6. And 15 degrees times pi over 180 is pi over 12. To go the other way, this is what I mean by it's all about the pi symbol. We have the pi symbol, we want to get rid of it. So now we're going to multiply with the pi symbol on the bottom and the 180 on the top. So the pi symbol is gone. So this is 90 degrees. Same thing here. Pi symbol on the bottom, 180 on the top. Pi symbol's gone, and we get 120 degrees. Now in part C, 4, it's not got a radian, it's not a pi. It is just a radian measure, but the pi symbol is not there. That doesn't change the fact that we're going to still multiply by 180 over pi. So you'll need your calculator for this one to divide by that pi. It's 229 degrees. This is a good demonstration of the importance of the degree symbol. See how this has no symbol? That's how we know it's in radians. Please do not make up your own symbol for radians. There isn't one. So no symbol, we'll assume it's radians. If you want it in degrees, you put the degree symbol on it, please. Now we're going to take a look at where are these angles located. Here are your quadrants, and they're labeled like the letter C. So 1, 2, 3, 4. Goes around like that. So if we think about pi over 5, so it says name the quadrant where it lies. Pi over 5, obviously very small. So right in through there. And so that's quadrant 1. Negative 4 pi over 7. Well, the best way to do this is to switch your whole unit circle to your denominator. So what I mean by that is that this would be 7 pi over 7, because that's the same thing as 1. So if we think about, okay, if I'm going from here to here, this mark about the halfway mark, well, half of 7 is 3.5, so that's a little bit more than 4. So we know that the 4 is over here some more. So I'm going to erase that because I can't draw my circle. My angle. So here's about 3.5. Here's where 4 would be, and it's negative, so we're going down. Remember, negative goes down, and so that looks like it's in quadrant 1, 2. So quadrant 3. 3 pi over 2. Pi over 2s are your 90s. Right, we realize that up here. Pi over 2 is 90, so 1 pi over 2. Here's 2 pi over 2. Here's 3 pi over 2, so it's right there. So the answer is right on this axis, so we don't have to draw the terminal side. So this is considered to be the negative y-axis. So let's do this again with 8 as the denominator. Okay, so start thinking about the process here. So instead of 1 pi, this is 1 pi, we're going to make it 8 pi over 8, because that's the same thing as 1 pi. So 11 is a little bit more than 8. So we know we have to go past here. We're probably going to land. It doesn't matter where you land. It's very inexact. I have a tendency to draw all mine so that they look like 45s, but it's totally up to you. And this is, of course, in quadrant 3. This is a very important skill and something that doesn't go away for months. Now, the way they have these described, this is not something that we really do, so we are going to skip this. How about that for speeding up the process here? All right. Coterminal angles. Explain how to find the coterminal angle in radians. So coterminal means that if here's our angle, you know, we can land there, we can go around this way, we can go around twice, we can go around 3 times, so it lands in the same spot. So if we're in radians, please do not switch to degrees and then do it in degrees and switch back. That's a horrible way to do it. We're just going to add and subtract 2 pi. That's it. Now your calculator will do this, but you'll have to make it switch back to a fraction for you. And do not put the pi in the calculator, because you will not be able to put that back to a fraction. You have to take care of pi yourself. So again, we're going to add 2 pi, and we'll subtract 2 pi. Making the calculator give you a fraction and putting the pi symbol back on top, you get 13 pi over 5 and negative 7 pi over 5. And again, we want one positive and one negative. So here we go. We'll add the 2 pi. We get 4 pi over 3. We subtract the 2 pi. We get negative 8 pi over 3. This one, of course, we're trying to make this smaller, so we're just going to keep subtracting 2 pi over and over and over again. This is a lot easier if you just think of it as subtracting 2. So if we subtract 2, subtract 2, subtract 2, subtract 2, subtract 2, subtract 2. So this ends up with just 1. So this is actually pi. This one, of course, we're going to have to add the 2 pi because it's negative, and so this one ends up at 8 pi over 5. The next step after you draw your angle is to draw your triangle. So now we're going to get into some triangle stuff here. Triangles mean basically anything goes. Pythagorean theorem, 30, 60, 90 rules. If you have a right triangle, you could also use, of course, any of your trig stuff, any of the side, opposite, adjacent, all that good stuff, trig ratios. So when we're in the first quadrant, you draw your triangle here. So we're creating this right angle. You always draw it to the x-axis. So what I mean by that is, let's say same picture, you don't draw it this way. This is a no. Absolutely never, ever, ever, ever do you do it like that. Always go down or up depending on the positioning of the x-axis. So if we're in quadrant 2, notice that our triangle is actually going to be outside of the angle. So if this is, let's say, 120 degrees, then we would know that there's 60 degrees till we get to the 180. In quadrant 3, again, you go to the x-axis. This is where your right angle would be included. Now with this one, it's kind of weird because it's bigger than 180. All right, so here's the 180, so we'd have to subtract from 180 to figure out how much that is. And of course, in the fourth quadrant, this is where we would draw it. So now we're going to try some of these. We're going to talk about side lengths and how to figure out these side lengths. Angles are usually easier because we can kind of subtract from 180 or add from 180, or we can work from 360, but when we're dealing with side lengths, we got to work with some other things. So it says we're going to draw a reference triangle and find the missing value. So the directions are up here, and so we're going to find OP. So if we think about this point, and we think about how it was created, we had to go right 3 and up 6. So you have to use the point to label your sides. And now we can use Pythagorean theorem because we're looking for this. Oops, I don't know what happened to there, sorry. We're looking for this right here. So this would be 3 squared plus 6 squared equals x squared. So that's 45. And then of course you take the square root of 45. 45 is 9 times 5, so it's 3 radical 5. So OP equals 3 radical 5. And we know back from geometry days that no symbol above the letters means length. So we don't have to do anything else for that. So again, if we think about how this point was formed, this was -4, +3. Now if you know your triples, this is a 3, 4, 5 right triangle. The fact that that 4 is negative won't matter, but if you're going to put this into the calculator, please don't. I hope you know what 4 squared is, but if you need to, you need to. It has to be put in this way. Otherwise, you will get the wrong answer. Your calculator will treat it as the opposite of 4 squared. So we have 16 plus 9, and then we're looking for that. So that's a 25, and then we take the square root. So here OP is 5. Now you can see they've kind of changed it on us a little bit. So the point is x -5. It doesn't change how the point works. This means we went x this way and -5 this way. And they're telling us that OP is 6. All right, so now we're going to have x squared plus 25 equals 36. I just went ahead and squared the 5, even though it's negative, we know it's positive. So then we turn out x squared is going to be 11, and we get that our missing side is the square root of 11. Now they're telling us that OP is 10, so this point was over 7 down y. So technically it's a negative number, but we're going to square it anyway, so we don't really care. And this, of course, is the 10. So 7 squared, which is 49, plus y squared is equal to 100. So y squared is equal to 51. 51's not prime, but it doesn't break down. Now, because this goes down, we know it's a negative value. So you're going to have to pay attention to that and make this a negative value. So y is equal to negative radical 51. All 6 trig functions, there they are. So however you know the trig functions, keep them. Don't get rid of them. Don't try to learn them a different way. And certainly don't try to learn the reciprocals. Right, so we just you know that however you know this, SOHCAHTOA. So sine is opposite over hypotenuse, that's what this stands for. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're not going to worry too much about the reciprocal functions yet. We would never put those in the calculator. We don't really use those for anything except when we're dealing with unit circle or some things we get into later with some more intense trig stuff. But for right now, I know that all 6 of them are there. We really are going to focus on the first 3, sine, cosine, and tangent. All right, so this has a lot of directions, but it's basically putting all this stuff together. So everything that we've just done, I know there was just a few minutes ago, but here we're going to do it all together. So we're looking for theta, or we're told that theta is an angle in standard position, which means it's been rotated from that positive x-axis. And so O is the origin. P is a point on the terminal side of theta. So we're going to draw and then find the missing value to 3 decimal places. So point P is 3y. So that means we're going to go over 3 and up y. There's point P. Then of course we draw the angle in there, and our angle, our theta, is 70 degrees. All we have to do is find y. Now when you do a problem like this, don't say, oh, this one I'm using sine. You don't decide. The picture decides for you. So of course from the angle, this is the opposite side. This is the adjacent side. So what uses opposite and adjacent? Tangent. All right, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So opposite and adjacent is tangent. So we're going to have to do tangent of 70 degrees is equal to y over 3. Now, of course, in your calculator, you'll have to go to mode. Make sure you're in degrees, because if you're not in degrees, you'll get a different answer. This is like cross multiplying. So we know that y is equal to 3 times the tangent of 70. Do not separate the tangent from the 70. They go together. Put that in your calculator. Make sure you're doing this right. You should get, we go to 3 decimal places according to the directions, 8.242. Let's try another one. OP is 20. Our angle is 38, so we know we're in the first quadrant. So this is our 38-degree angle. This is O, of course. This is P. This is 20. We're trying to find the coordinates. Oh, so we need 2 things. We need X and Y. It's important that you label them correctly. X goes left and right, Y goes up and down. So we're going to have to do this twice. I'm going to do X first. X is the adjacent side. Y is the opposite side. 20 is the hypotenuse. So if I do X first, adjacent hypotenuse is cosine. So cosine of 38 is equal to X over 20. And again, this is a multiplication problem. 20 times the cosine of 38. Don't separate the cosine from the 38. We get y equals, sorry, I was looking at my work. It looks like I wrote down a 10. I don't know why I wrote that down. Y equals 12.313. Now for y, oh, that was X, sorry. Now we're going to do y. So this would be, now we're going to do opposite and hypotenuse, which is sine. So sine of 38 is equal to y over 20. And sorry, that's a y. And so now we get, put that in the calculator, we get that y, I have these switched. This is 12.313. This one, X, is really, sorry about that, 15.760. For part C, if our point is 6, 6, we're trying to find theta. So think about plotting that point. Don't think about anything other. We don't care about the angle. If I were to graph 6, 6, I'd go over 6, I'd go up 6, it'd be right there. It'd be in the first quadrant. So what do you know when the 2 sides match? What kind of angle is that? Anyone? It's a 45-degree angle. So we don't have much to do here. We know that theta is 45 degrees. All right, so 220, finally we get to one not in the first quadrant. So you start by drawing your angle, like that. So 220 is over here. So this is 220. We don't care about the 220 because all we need is this much space right here. So we have to do 220 minus 180. That's 40 degrees. So we need the fact that that's 40 degrees right there. That's the part we're looking for in order to help us find the problem. We're trying to find the coordinates of P. There's P again. This is X. This is Y. Now, you're going to get positive answers. X and Y are both negative because of where they're located. You got to pay attention to location. So if we do X first, cosine of 40 is equal to X over 12, because this is a 12. And so we get that X equals, you get 9.193, but it's negative because of the location. So you got a lot to pay attention to here. For the Y value, we do the sine of 40 is equal to Y over 12. And we get Y, again, Y goes down, so it's negative. negative 7.713. This is absolutely a lot going on here. All right, now your assignment is actually on this page right here. In case you don't have this somewhere, you should. This is page 196. Please do not do number 21. This is not something that we did. We did not do angular and linear velocity on purpose. And please do the rest. So 19, 20, 22, and 23.